here that I'll share. And yeah, so thanks to Michelle for inviting me to this. So I get to talk about a topic I'm really interested in, which is trying to use data to make better decisions. So I'm going to share my screen. I'm going to try to leave my video on, but if it's lagging or anything like that, someone just tell me and I'll turn the video off. So let me know when you can see the presentation.
Perfect. Yes, you are good to go.
Yes.
Okay, great. All right. So it should take, I don't know, about 20, 25 minutes. But feel free to interrupt with questions. And if you put questions in the chat, I might not see them immediately, but I can kind of check it periodically. So, all right. So I'm going to talk about A/B testing, and I'm going to talk about it more like the concepts behind it. So what you're trying to do and how you would go about setting up a test so that the results of the test will be useful to you. I'm not really going to talk about statistics that much, although that is what ultimately goes into analyzing the results of the test and telling you whether you've seen a meaningful preference for one of the two versions of what you're presenting to users. So it's not really going to be a talk about statistics, but I will mention a little bit of that side of things and give a simple example of some of the types of reasoning that you would use at that point in the testing. So to start, so here is a beautiful feature on a website, and there's two different versions of this feature. So both of them have a sign me up button, and one of them has a green background and one of them has a blue background. And we'd like to know, so we're maybe considering both of these versions, and we want to know, does one version make users more likely to press the button than the other version? So that's what we'll be trying to test. And we're not really concerned about whether users prefer blue or green. We really just want to know about their behavior when they see this thing. So we're not going to ask them directly, do you like, a blue or green design for this feature? We're just going to see whether making it blue or green makes more people press the button. So that's the sort of philosophy of what we're going to be doing here. Now, let's get a little bit more precise about what we're doing. So if a user clicks the sign me up button, sorry, my cat's attacking the keyboard here. Got way ahead. He's interested in the later part of the talk.
Love it.
So if a user clicks the sign me up button, we'll call that a conversion. And we obviously want to get as many conversions as we can. And so we want to know, does one of these versions lead to significantly more conversions than the other? And the key word here is significantly. So when we run this test, we're almost always going to have people click the button more for one of the versions than the other. It's very unlikely that people in the two groups that we're going to make click the button exactly the same amount of times. So it's always going to look like one version did better, but the thing is how much better? And that's what we're going to try to analyze. That's where the statistics part comes in, is that, okay, more people click the button in the blue version, but how many more? Is that a real difference, or is it just, due to random chance, there were more people that liked blue online that day when we ran the test. But if we did it another day, it could have been the other way around. So that's the type of a challenge that we'll have to deal with when we look at the results. And that is the part where statistics comes in. So what we're going to do in a nutshell is we have these two versions of this feature, this button, and we're going to show the two versions to two different groups of people. So each group is only going to see one version. They don't even know the other version exists. They just see their version. And within each group, a certain number of people will click that button, and we'll see which version gets more conversions. Most likely, one group will get a few more than the other group. And then we'll use statistics to decide if the difference that we see is significant or if we think it's probably just due to random chance. So any questions on the basic setup? I haven't checked the chat yet.
There's no questions. So
Okay.
we're good. Yep.
All right. I'll keep going. So now I'm going to talk about the setup of an ideal A/B test. This is sort of the most rigorous test you can do in terms of giving you results that are most reliable to analyze with usual statistics methods. So in this test, the idea is that you're going to show this feature to a specific number of people. So let's say it's 400 people. And what we'll do is we'll randomly divide that set of people into two groups of equal size, so 200. So two groups of equal size, 200, and we shuffle the people around randomly into two. And the randomization part is really important, and we'll talk about that in a little bit, but I want to highlight that part of this setup. And then we'll show the two groups, the two versions of the feature, and record the number of conversions for each group. And that'll be the basic data of the A/B test. And so you don't always have to do the test that way. There are some reasonable alternatives that you can still analyze in a pretty rigorous way. So one is that instead of fixing the number of people, we could fix the amount of time. So we could say we're going to run this test for a week, and then at the end of the week, that's it. We've got all the data and we'll do the analysis. But if you do it that way, then the number of people is not fixed anymore. So you have to understand that you don't really know how many people you're going to get in that time, and you may have to choose the time wisely before you run the test to make sure you get enough people. And so in this case, the randomness is still an essential ingredient. So now you're running this test for a fixed amount of time. When a user arrives at your website, you have to still randomly decide to show them either version A or version B. So it's like when someone comes to the website, it's like you're flipping a coin. And if it's heads, you're going to show them version A, tails, you're going to show them version B. And so the groups here are not guaranteed to be the same size as before, or like they were before. But if you get enough people coming in, because you're essentially flipping a coin to decide whether to show them version A or version B, the groups will be close to the same size. So if you think about flipping a coin 1,000 times, you probably won't get exactly 500 heads, but you'll probably get close to 500 heads. So the groups will be nearly the same size if you get enough people coming through. And in this case, since the groups won't be exactly the same size, instead of studying the number of conversions and comparing that between the two groups, you want to compare the conversion rate, which is the number of conversions divided by the group size. So number of conversions as a percentage of the group size. And we'll compare that between the two groups. Now, there are some other possibilities, like you could decide that you'll run the test until you get a certain number of conversions. And that could take a really long time. You know, you could say, we're going to run this test until we get 100 people that click this button. That's a valid way to do it, and you can still analyze it rigorously, but it may take much longer because at that point, you don't know how long the test is going to last. You just have to run it until you hit that situation. So these are the main two ways. And the reason that you usually fix either the number of people or the duration of the test is because if you don't agree on that beforehand, you kind of open yourself up to this idea of, well, we're not quite seeing anything yet, but let's just get a few more people, or we'll take a little more time and do the analysis a second time. And when you do that, you can start to find weird things, like it looks like the results are reversing each other. So really, it's best to decide in advance that you're either going to take a fixed number of people or a fixed amount of time. So what about the randomization? So I mentioned that it's really important in all of these different types of tests that you could do. And the reason is that you want to avoid the influence of confounding factors. And so here's an example of a confounding factor. What if we don't randomize and it happens that, maybe we just, everybody who shows up on Tuesday, we're going to put them into group A. Everybody who shows up on Wednesday, they're going into group B. But it turns out that on Tuesday, we got 200 teenage girls, and on Wednesday, we got 250 to 60-year-old men. So in that case, what are we actually testing, right? We can expect that the very different characteristics of these two groups may be influencing the test. So that's a confounding factor. In this case, it's the age or gender or any other characteristic of the two groups that's maybe different between the two groups. So the point of randomization is to try to wash out those differences by shuffling people so that each group is just this heterogeneous mixture of all different kinds of people. And each group is not dominated by one type of person. So that's the idea behind the randomness. And let's talk about the confounding factors a little bit more. So here, this diagram is meant to represent the different factors that are at play in this situation and the directions of influence of these one onto the other. So we have, on the one hand, the version of this feature that we're showing to people, A or B, and we're interested in the effect of this version on people's behavior, which is whether they converted or not. So that's represented by the red arrow. But if you don't randomize, then sitting up here, you have any number of different confounding factors: age, gender, income, location, anything you can think of that might influence a person's behavior. And if the makeup of the groups is not uniform, then these factors are influencing the makeup of the groups. And they're also influencing people's decision to click the button or not by this blue arrow. So we'd really like to study the effect represented by the red arrow, which is that, if we show everyone version A, are they more likely to click the button than if we show everyone version B? But how could we untangle that from the effect represented by the blue arrow? So in the kind of situations where you may have a design of some feature and some type of technology, be it a website or app or anything like that, the usual answer to this is you want to randomize. And the randomization kind of cancels out the effect of these confounding factors. And you can think of it as severing these arrows, and then you just are left with the direct effect of your choice of the version on whether or not people click the button. So you can think of randomization as washing out or averaging over the effects of this confounding factor. And it lets you test out the true effect of changing the version. So there are some cases in science and medicine where you can't use randomization to solve this problem. And it's pretty interesting. Those type of problems are out there. So maybe it's interesting to talk about one of them. So imagine that instead of the two versions and seeing if someone clicked the button or not, we have a drug that we're giving to people, and they'll either take the drug or not take the drug or take a placebo. We want to know if they have, say they have some condition, and we want to know if they get better or not. And again, all these factors that are listed here in this top bubble would influence that type of experiment as well. So we can think about different experiments like that. So imagine that we have a group of 100 people and they all have seasonal allergies. then we could probably get that group of 100 people to agree to a randomized trial like we were describing, where we're going to give 50 of them a medication for allergies and 50 of them a placebo, and we'll see, and we'll, you know, assign them randomly to the two groups, and we'll see if giving this medication has any positive effect on their allergy symptoms. So you could probably get that group to agree to that experiment. But now imagine instead that this is a group of 100 people with a rare cancer or something like that, and there's an experimental treatment that could save their life. In that case, you know, ethically, you can't do that experiment. The best you can do is you can give people the option to take this medication or not, and they'll decide of their own free will whether to take it. And in that case, all these confounding factors will play into their decision to take this medication or not, and whether they'll recover from it. So in that case, you can't solve this confounding factor problem with randomization. If you want to study whether the drug is effective, you're stuck with the data as you have it. And there are methods to study some situations like that. It's called causal analysis. It's pretty interesting. I recommend looking it up. Actually, I will, if you're interested in that, I'll type into the chat. There's a book called The Book of Why by Judea Pearl, who's one of the main scientists who worked on that. But in this type of A/B testing setting, we can do randomization to get around this issue. Did see one question in the chat. So the question is, do people sometimes collect age, gender, income information to ensure the distribution falls along a normal bell curve? So you can do that, and actually if you did collect that information, that might be something you would want in this case where you're actually stuck not being able to randomize. If you were stuck in this situation and you wanted to do that other type of analysis that I was talking about, you would need all that information that was mentioned in this question. So you would want to measure the age, income, know all these characteristics of everyone in the group, because they would be used to do the analysis. So you wouldn't necessarily check if they were following a normal distribution, but you would want to know the distribution in your set of participants. Another question, would you recommend controlling for these confounders in the statistical model? So if you can randomize, then you would use this other method that is exactly made to control for these confounders. But you can randomize them. The best option is to just randomize, which will wash out the influence of them. So, okay. So then the next thing is, how will we tell if the difference is significant? So if we go back to our two versions of the button, let's say we did the experiment and we found that 48 out of 200 people clicked the button with version A, and 57 out of 200 clicked it with version B. So version B did better, but is it significant? Is version B really better? Is this gap between 48 and 57 big enough to conclude that in the long term, we're going to get more clicks if we go with version B? So that's where the statistics comes in. And for that, I just want to kind of describe the main ideas of the analysis that you would do to make that decision. So the main idea of what you do is you say that, well, let's assume, what you do is you follow the idea that what if these results are just due to random chance, and that there's actually no difference really in how many people will click this button between these two versions. So you're going to follow that idea and try to quantify it. So you assume that users actually have no preference between these two versions, meaning that their probability of clicking the button, so a new user comes into the site, the probability that they're going to click that button, we're assuming it's actually the same for the two versions. So we'll take that assumption, and under that assumption, we'll calculate the probability of seeing a difference in conversions that's as big as the one we saw or bigger. So here, so 57 minus 48, so that's 9. So we're going to calculate the probability of seeing a difference of 9 or more between the conversions under the assumption that people actually don't really have a preference between these two. And so what this represents is the probability that the difference we're seeing is due to random chance. And then the key point in this statistical reasoning is that if that probability is small, then we'll conclude that users really do prefer version B, or that version B is more likely to make people click that button. So that's the key. So we're calculating the probability that it's due to random chance. And if that probability is small, then we'll say, okay, it's too small. We'll conclude that it's not due to random chance and that version B really did perform better. So that's the main idea. And so for this, I'll actually want to give an example of this type of reasoning in a simpler setting, where instead of looking at two versions, we're just going to look at whether people like or don't like one thing to kind of get a feel for how that kind of reasoning is done. So, okay, so this is a really silly example, but suppose that Netflix thinks that viewers don't like their new show, Is It Cake? Okay, and to test this, they ask viewers to rate it with a thumbs up or thumbs down after watching the first episode. And so suppose that 5 people watch it, but only 1 of 5 gives it a thumbs up. So can we conclude from this that people generally don't like this show? Okay, so we're going to follow the logic from the previous slide and to try to quantify this number of only 1 person giving it a thumbs up. So like before, the first step is, let's assume that viewers actually have no preference about the show. Because remember, we're trying to see the probability of this 1 out of 5 thumbs up occurring if people actually don't care, they don't have a preference. So we'll assume that each viewer who comes in, they're going to give a thumbs up or thumbs down with a 50-50 chance. So just like flipping a coin. So we're going to look at the probability of seeing 1 or less thumbs up in that case. So we've got 5 viewers, and each of them have 2 options. So that gives us this 2 to the 5th power, which is equal to 32. That's the total number of possible outcomes of thumbs up or thumbs down for these 5 viewers. And we want to just consider the cases where there's 1 or less thumbs up. So if there's 0 thumbs up, there's only one way for that to occur. Everyone has to give a thumbs down. So that's this 1 out of 2 to the 5th. And then there's 5 ways to get 1 thumbs up, because just 1 person has to give a thumbs up. So any one of the 5 people could do it. So the total probability of seeing 1 or less thumbs up under our assumption is 6 out of 32. So whatever it is, 0.1875. So this now, remember, is representing the probability that the numbers we saw are due to random chance. Now this is pretty low, so we can maybe in this case conclude that the results are not due to random chance and viewers actually don't like this show. So one kind of technical point that I glossed over here is that you have to decide what you mean by pretty low. So this means that you set a cutoff where if the probability is below some number, you're going to conclude that it's unlikely that it's due to random chance, and you're going to accept that there's a real effect there. And that's called the significance level, is that cutoff. So in scientific research, they usually use a cutoff of 0.05, meaning a 1 in 20 chance that this happened randomly. So you see, this wouldn't pass the test in the scientific journal. But in this case, we have a small number of viewers, just 5, where it's reasonable to take a larger cutoff, like 0.2, so a 1 in 5 chance. And in that case, we would say, all right, it looks like this result is significant because it's below 0.2. And the effect of raising this significance level, it means that you're okay with getting more false positives. It means that in some cases, 1 out of 5 times, if you set your significance level to 0.2, you will see a big difference just due to random chance. And so 1 out of 5 times, you might get a false positive, but you're accepting the higher risk of a false positive so that you can catch the cases where there's a real effect there. So one example of a situation that's kind of like that is, like, if you think about airport security, when they swab your laptop or something like that, and they're testing if there's possibly some dangerous substance there, you can imagine that they're using a large significance level, whatever it is on their scale, like 0.2 or something, because they don't really care how many false positives they get. They can quickly resolve it by looking more closely at the person's stuff, but they really don't want to miss a case where there is something there. So you can think of that as a case where you might set the significance level really high. But in scientific research, they tend to set it lower. So, all right, let's see what's next. So, all right, so that's the main, bulk of the talk. I did see there's one more question, and then I want to conclude with some things that you can ask the person who's analyzing the results of the test. So in what way would a timer while A/B testing change the outcome? So Nick, would you be able to tell me a little bit more about the situation with the timer?
Yes. While the participant is testing, the participant is A/B testing. In what way the outcome will change if there's a timer like 5 or 10 seconds while he is choosing between A or B?
Oh, so they can only, okay. So I think, so in the type of test that I'm imagining, people will only ever see one version. So someone who sees version A doesn't even know that version B exists. So it's a little bit different from that type of scenario where you're allowing them to choose. So in this case, the type of test I'm talking about, we're really looking to see whether the choice of the color influences their decision to click the button. We actually don't really want them to know that there are multiple versions out there. We're just trying to see if by us changing the color, it has some effect on their behavior of clicking the button. So, but I think there are other cases where, definitely there are situations like you're talking about, but the one that I'm talking about, they wouldn't be making a decision between the two. Can we study how long it took a user to click the sign me up button? Yeah, you could totally do that. You could think of, there's a lot of interesting stuff that could come of that. I don't think it would play directly into this type of analysis, but yeah, it would definitely be interesting thing to look at. You could look at the distribution of that time. So yeah, so the last couple of things I wanted to say are just a couple questions that you can ask if someone else is going to be doing this analysis of the test results for you, to just make sure that they're doing it right. So the first thing I would always ask is if they randomize the test to eliminate the influence of confounding factors. And if they didn't randomize it, then you would have to ask what they are doing to control the confounding factors. And then the second thing that I would ask, and not necessarily because you're going to use this technical knowledge, but just to make sure that the person who's doing the test knows how they're going to analyze the situation, is you can ask what tests did they use to analyze the data, and is it appropriate for the size of the sample and the conversion rates that you observed. So in that example we were doing with the Netflix thumbs up, thumbs down, we actually analyzed the situation exactly by calculating all the probabilities of the different scenarios of thumbs up or thumbs down between the 5 users. And so there's tests out there that are called exact statistical tests that do something very similar to that. And they're not really a subject in introductory statistics, but they are out there. And they're what you would want to use if you had a small sample, or if the conversion rate that you were getting was pretty low. Like, you know, in those examples with 200 people, if the conversion rate was 5 out of 200 in one group and 8 out of 200 in the other group, you would need to use these more specialized methods to understand that. On the other hand, if the samples are large and the number of conversions is pretty large, you can use more approximate methods that you would learn in introductory statistics. So it's a good question to ask. At least it gets people thinking about the problem and whether the type of analysis they're doing is appropriate. The other thing I did want to say about this is that sometimes you'll find that the total number of conversions is very low. So between the two groups, you know, the number of conversions in group A plus the number in group B. And in that case, you'll find that you can't really say anything. The statistical analysis won't show you that there's a significant difference between the two groups. And what's really going on there is you don't have enough information. So at that point, what you probably have to do is say, well, this is not the appropriate time to be comparing two different versions of this. We actually have to revisit the whole concept of this feature and see why we're getting so few conversions. So that's a thing that can happen. And, you know, we've had projects where that's happened. And when you see that type of thing, you have to say, okay, we shouldn't be trying to compare different versions of this feature. We should be revisiting this whole feature and seeing why we're getting so few conversions. So that's all I've got. So happy to answer some more questions.
And I have a question. So this is super sure. So the A/B test that you showed was a very simple like button change or a color change. Would you recommend that you only have very minor changes at a time? Or let's say you changed all the buttons on the page or all the fields on the page. Would you recommend you do them one at a time, or you do everything on a single page at once and then have 2 versions of it? Like, what are the recommendations there?
Yeah, I would tend to suggest doing smaller changes one at a time, because you run the risk of not being able to tell which change really, you know, made the change in user behavior. So yeah, if it's possible, I would suggest to make smaller changes and test them one at a time.
Thank you.
Sure.
Matt, hi, thank you so much for the presentation here. Very informative. My question is very similar to Sue's. I was wondering if a factorial design would apply there. So maybe we're doing a small change, keeping everything the same, then 2 changes, etc. Because sometimes a small change may not be the one that's converting, even statistically speaking, even if it may be the key and the holy grail. Sometimes it's hard to see it because of the low conversions that we have. Would you recommend that?
Yeah, so absolutely. So yeah, maybe just to, so in a factorial test, you're testing several different changes, and not only each change, but also possible interactions between these changes. So you would, like, let's say there were 2 different colors and 2 different phrases that we wanted to test on those buttons. So in the factorial test, we would actually have 4 different versions where we would change the color and change the phrases. And we would check maybe there's one particular combination of the color and phrase that's the best. So yeah, absolutely. I would totally recommend that. In that case, you just need a bit more sophisticated analysis to decide if there's a real winner. But yeah, definitely.
Thank you. Thanks, Matt. Yeah.
We have some questions in the chat. And I actually kind of want to add to one. So the first question is there a minimum number of participants for A/B testing? And I also wanted to add, what would you consider statistically significant for the sample size?
Yeah, so minimum number of participants, I would say you really want to get, so even for these exact tests that I was talking about, you really want to get at least, 10 to 15 people in each group. But really the more is always better. And in some cases, especially with clicking things online, sometimes the conversion rates are so low that you really want to get as many people as possible. The other thing that you can do is the second part of the question, which is decide, to raise the significance level that you'll accept in terms of deciding whether the result is big enough to be considered significant. So in that case, for some things that we've done with small samples, I would actually use the 0.2 because just kind of the philosophy is we don't want to miss a real effect. And in this case, the real worst case scenario is that there's no preference between the two. So, we might be falsely concluding that there's a preference when actually there wasn't really one. And in that case, we haven't lost too much. But if there is a preference, then we probably caught it by raising our significance level a little bit. So I would consider raising your significance level. You could do 0.2 or you could do 0.1 to be a little bit more conservative. You don't have to do the 0.05 that you normally hear about when you read a news story about a scientific study or something like that.
Okay.
Yeah. And yeah, so that's what I would say. And that's something that we have done. The key thing is really just to decide on what significance level you're comfortable with beforehand. You don't want to make the decision after the data is in.
Okay, that sounds great. Thank you.
Yeah, sure.
We also have another question in the chat from Paris. She says, if we don't have or collect the age/gender/income information, how can we make sure the test is randomized, or can we assume?
Yeah, so the key thing is here that no matter which person's coming in, you're going to flip a coin and use that to route them randomly to each version. So that you don't actually have to know the characteristics of the people coming in. You're just always going to shuffle them randomly. So so the randomization will work without knowing any of that information. And actually there are a lot of online platforms. I haven't personally used them, but some people in our company have used them a lot that set up these A/B tests for you. And that's exactly what they do. As a person comes in, they randomly send them one way or the other. And in doing that, they don't look at any of their information, where they're logging in from, what their device is. They just flip that coin and send them somewhere to one of the two versions. So the randomization does work, even not knowing that information. In fact, it's even better to not know it.
Very cool. Yeah, I had another question, but you kind of answered it. I was going to ask, do you have tips for randomization? But it sounds like you're kind of suggesting, using products that are out there, coin flip.
Yeah, I think there's products that are out there that probably do it in a very sophisticated way and keep control of all that stuff. But it really, at its heart, it's like doing a coin flip. You can think of it as like, if 100 people came to your house and you were going to present them two versions of thing, as each one comes up, you flip a coin and you send them either way. it's the same concept. It's just a piece of code that's flipping the coin instead of you doing it. When the size of the groups is fixed, it's a little bit more complicated than flipping the coin, but you can imagine, you know, let's say the analogous situation to flipping the coin when the size of the groups is fixed. So let's say you've got 20 people and you need to randomly pick 10 of them to go into one group. You can imagine, you know, you take a bunch of 20 marbles and put them in a hat so you can't see them, and you grab 10 of them out, you know, that's the type of situation. But it's those type of things, but just being done by code that's doing the randomization for these situations.
That's what I kind of figured, is that you could kind of set something up via code.
Yeah.
Awesome. Does anyone else have any questions?
So I actually am not an expert on this part, unfortunately, of the online tools. But I think Michelle can probably connect you with someone who is, though, and who would be able to answer that question.
Okay, cool. Thanks.
Yeah, no problem.
All right. So if we have no more questions, we were going to kind of do sometime afterwards to do kind of like a show and tell and feedback. But we're kind of running a little late on time. And I'm kind of thinking if you guys have something that you'd like to kind of share with the group or present in any kind of way, we could fill out the time that way, or we can just end it early. Kind of up to you all. Not seeing any hands go up. So you know what? I think we're probably will be all good. I think next week, you know, even if you guys want to, or not next week, next month when we have this. So it happens on the first Tuesday of the month. Typically we take off this, or what is it, January and July. If you guys want to come with any examples of current work, or maybe even just like a portfolio URL, we can kind of take a look and see what you got. But Sue, do you have anything else?
I do not.
All right, well, let's hit it. All right, thank you everyone for making the time to come out and come to the meetup.
Thanks.
Thank you
Yes,
all.
and
Thank you, Matt.
thank you, Matt, for your time today. This was a great
Yeah.
presentation.
Sure. Thanks for having me.
All right. Very cool.
Well, I think we can, I'm going to stop the recording.